Hi guys, in this video, I'm going to introduce the supercapacitor. What is a supercapacitor? Supercapacitor is a device consisting of two porous electrodes separated by an ion conductive membrane. The electric field created between the electrodes and electrolyte makes the energy storage easily in the electrode. In this photo, you can see the separator and porous carbon electrode. Let me explain why this is important for supercapacitor. Separator in a supercapacitor is used as a sandwich between two electrodes. The essential function of separator materials remain the prevention of the device from short circuit, storage of electrolyte into its pores, and passage of ions during charging and discharging process. And in terms of porous electrode, it has many advantages. It provides better control over the distribution of the reaction. The two solutions are separated by a porous barrier that prevents them from rapidly mixing each other, but it allows ions to diffuse through. This is the process of charge. A capacitor charges positive charge on one plate A and negative charge on the other plate B, and the charge moves until the potential difference between the two metal plates is equal to the voltage of the battery, so that the charge is distributed in the same amount. In this state, even if the battery is separated, charges are stored in the two metal plates by electrical attraction between charges. You guys might wonder the difference between other types of battery compared to supercapacitor. What is the special characteristic of supercapacitor compared to other type of battery? First, what is the difference between battery and supercapacitor? Batteries store charge through a redox reaction, as we learned before, but the supercapacitor stores charge by the process that ions of the electrolyte are observed and deserved on the electrode surface. For next one, the next thing you might wonder is going to be, what is the difference between just capacitor and supercapacitor? Supercapacitor has bigger plate and shorter distance between the plates compared to the capacitor, just the capacitor. The bigger area or the shorter distance between plates, the higher energy is stored. In addition, it has lower resistance. As you guys know, resistance consumes voltage, so when the current flows through resistance, the voltage decrease immediately. So, which means lower resistance is very meaningful when it comes to delivering high power. Supercapacitor has actually three types: double layer capacitor, pseudo capacitor, hybrid capacitor. First of all, for double layer capacitor, the electrical double layer capacitor consists of symmetrical activated carbon electrode separators and electrolyte. They are charged by the process that electrolyte ions in the electrolyte are observed to the electrode surface in order to store charge at the electrode-electrolyte interface. For pseudocapacitor is slightly different. It is charged by an electrochemical redox reaction. Unlike just normal capacitor that store energy using only electrostatic charge, protons in electrolytes induce power charge transfer through electrochemical reactions on the electrode surface. You know what? The next one is hybrid supercapacitor, which is the best capacitor mixing the advantage of double layer and pseudocapacitor. Okay, this is a hybrid supercapacitor. In this photo on the right side, the pink part is an anode, and then the gray one is a cathode. And the sky blue color indicate an electrolyte, and the dark blue is a separator. Compared to the other supercapacitors, hybrid supercapacitor has higher operating voltage and much higher capacitance, which is the ability of a system to store an electric charge and energy density. I think up to 10 times. The principle of hybrid capacitor is that different asymmetric electrodes are used for the cathode and the anode, so that one electrode used an electrode material with high capacity characteristics, and the other electrode used an electrode material with high power characteristics. A capacitor capacity is given as 1 over C. C is capacitance. And it is charged from negative C to positive C. So the total capacity is determined by C plus, just like on the left side in the photo. In general, the operating voltage of a supercapacitor is determined according to an electrolyte, but in a hybrid capacitor, the internal voltage of the cathode becomes the operating voltage of the hybrid capacitor, and thus high voltage is possible. Okay, thank you for watching video. Have a nice day.